Hi everyone. So we are going to do the first example of the linear optimization problem that looks at state parks planning two new public recreational sites with a budget of 120,000. They have 80 acres that is wilderness areas, and then they have about 20 other acres that is suitable for turning into hiking and sightseeing. They need to figure out how much of that land in that hiking that they want to be able to develop for trails. So to begin, we're going to kind of think about what are we asking. Well, we're trying to figure out how many acres, when we look at this, how many acres are we going to keep into wilderness? How much are we going to designate into hiking trails? And each one have differing cost points. So if we're thinking about wilderness, we're thinking about hiking and how many acres for each one of these. For the first one, wilderness, let's just say for each acre, it's an acre of wilderness. The constraint is direction. Let's say the direction of the constraint is it equal or greater to the current constraint, which is 80 acres. Then for hiking, we have we're an area of hiking is 1 acre, and we need it to be less than or equal to, let's say, 20 acres that we have available that we can turn into a hiking area. And then each one has cost. For wilderness, for that first row, it is 1,000 per acre to keep up and to keep up the maintenance, as well as like maybe patrol or remove garbage and stuff. For hiking, it's 4,000 per acre for those particular areas, and we need it to be less than or equal to their budget constraint, which is 120,000. Now, their main goal as a public institution is to maximize recreational hours, right? So what we know for wilderness, it's a little bit more difficult to get in and to enjoy. So there's not as many people who enjoy it per day. But on average, a total of 10 hours of recreational time is spent there per day. And in the hiking area, there's much more people. And if you add it up, it's about 20 hours. And that is something that we want to maximize. So that's their main goal, is maximizing the expected average hours of visiting in the area. So our main question is how many acres, right? That's what we want to know for each one of these. So these particular guys right here are going to be the variables or the cells that we're going to leave open for Excel to try to maximize, to figure out the optimal level of each one of these particular variables. And the thing we are also is interested in is how many hours, max hours, is the optimal level that we get for how many acres we designate for each one of these guys. Okay, so we have wilderness, we have hiking, and we have cost. Those are all various different constraints we have. And a few of them, let's say right here, what we have available is this level of 80, 20, and 120,000. But what we use is going to be a sum product of taking this equation, taking this 1 times 0 basically over here in hiking, times what Excel spits out in these two cells that are going to change and vary to find the optimal amount. Now, this is the same thing that will happen when we want to look at constraining the hiking area, right? So we're going to take, this 0 and 1. We're going to times it by this particular cells as it varies, but we need it to be constrained by the available, which is 20. And lastly, sum of product, we're going to need to look at how much it cost over the changing cells that when we optimize to get at how much, or to stay within the boundaries of our budget, which is 120. So for example, right now, the way we set it up with using the sum product, if I put 1 right here, it's going to change this cost to 1 because it's going to times 1 by 1. And it's also going to change wilderness. Now, if I was to say change this to let's say 1 acre, it's going to now change this column, this cell, into 4, because it's going to times the 4 by that 1, or the 1 by that 4, and we're going to get back a $4 cost. And we're also going to get a 1 in the hiking area. So this sum of product is basically doing a calculation of timesing each, kind of a linear matrix, and timesing the corresponding variables to one another one. So here to this one, this guy to this guy, and then summing up the product. Lastly, we want to maximize this equation where we have our maximized hours by these area that is now currently 0. So this is going to return 0, but that's what we want to do. We want to have that maximized. So now we can go into our solver up here in our data area. And first, we want to select the maximized variable, or the variable that we're trying to optimize. And so for this guy, the way we have it set up, we have it as B10. The variables that we are changing are going to be these two guys, right? And then for our cells of constraint, we have these products, which are going to be less than or equal, these products, bring it over here, which is going to be less than or equal to these guys. So now we have those, are they less than or equal to our constraint? And they're all the same, so we can just do this all in one little added constraint. So, let me move this over here. What we have here is we have B12, we have these changing variables, we have our constraints on the bottom. We want to make our unconstrained variables non-negative because acres cannot be negative. And all of our equations here are basically just timesing one number by another. So they're very linear. We're not having any type of squared or nonlinear behavior where it's curved or decreasing at increasing rate, nothing of that. So we just want to do a simple linear problem. And now when we solve this, move this over here, we can see that we have 1,000 hours. We have 80 acres dedicated to hiking and 10 acres dedicated to development of a hiking trail. And so now we can even include these sensitivity and limit reports to really take what we have listed here and make a really nice fancy little report for what we've done. So if we go to our results, basically it shows us that our max hour value, our optimal level, if we can zoom in here, here I'll zoom in. It suggests that the max hours of wilderness, or just max hours times in general, is 1,000 hours. We use 80 acres of our wilderness areas. We use 10 of our hiking. It started out at 0 and it increased up to 80 and 10. And then in our constraints, we can see that wilderness was binding. We used all of the area of our wilderness. But hiking, we actually have 10 acres remaining that we did not develop because it was too costly. And we have used all of our budget. Here's the slack variable. Slack indicates how much is left over from our optimization. Now, our sensitivity reports provide things like the shadow prices, which is here. Let's see if we can get out to here. Our sensitivity analysis gives us information on the shadow price, which is how much would it cost to increase one of our units of the areas variables that we're changing. So here it's acres designated to hiking and acres designated to wilderness. And the shadow price basically says that for about each increase above 80 would cost, have a shadow price increase in the total cost of 5, or so 5,000. The constraint side is 80. The allowable increase and decrease of this value, thinking that it's $5, is 40 on either side. So if you did have 120 acres, it'd be 5 $1,000 for each additional acre that we increased up until that 40 that we has as allowable increase. And then for the decrease for each unit below 80, so 79, 78, 77, all of those would decrease by about 5,000. And that's only conferable up to the 40 acre units, so down to 40 acres of wilderness. And that can be helpful in understanding like what's at the margins of increasing or decreasing the optimal solution for your type of report that you're generating. And so that can be kind of helpful in just understanding what occurs just above or just below the optimal solution provided. Okay. Yes. So now I think that's going to be, I'll post this one and then we will see if we need another one. Yeah, down the road. Okay.